So in the previous few videos we've been doing scalar line integrals, and today we're going to be doing vector line integrals, and the most common usage of that, which is questions on work done. So what we're going to do is just going to go through very quickly the theory behind it, and then we're going to do a question in the two ways that you can do it. Very common question. Okay, so we've got the line integral of a vector field f over a curve C is this, the integral over C of f dot, that's the dot product there, of two vectors, f dot dr, where f of x, y and z is p x, y, z, I, add q, x, y, z, j, add r, x, y, z, k, and C is a smooth three-dimensional curve given by r of t vector is x of ti, add y of tj, add z of tk for t between A and B. Okay, now we can also we can also write that in t form so that we can integrate it, converting everything to t. So converting our vector f to f of r of t, which basically is just replacing the x, y and z's here by the x, y and z, their t equivalent in the parameterization, and this will be t equals b to a of dr dt, which is the derivative of that, times dt. Now that one there is formula 1, and that is the main way that we solve work done questions, and we're going to do one using that formula. But there's another way that you can do it as well, which is here. So if we differentiated the vector r with respect to t, just taking this down here, we'd get dx dt I, add dy dt j, add dz dt k, and then what we can do, this thing here converts to this, and this is a dot product, and when we dot product these two, we get that it's p dx dt add q dy dt add r dz dt, and the dt's sort of cancel out, leaving us with this one, which is formula 2, the integral over the curve of p dx add q dy add r dz. And both of these ways here are identical, but just different ways of solving a vector line integral. So let's do the question, and we'll do it both ways. We'll do it this way first, and then we'll do it this way here. Okay, so here's the question. Anybody wants to do it, pause the video now. Okay, so the object moves from the coordinate 1, 0, 0 to the coordinate minus 1, 0, pi along the path r of t vector, which is cos t sine t t. That is the parameterization of the path, subject to the force F, which again is a vector, function of x, y and z, y squared, x, z. Okay, now first of all what we're going to do is we are going to use our integral t equals b, t equals a, f of r of t, this is the thing that I've done up just above, I'm just rewriting it out, dt dt. Okay, so f of r of t, what's that? Well, that basically means that we have to replace the x, y and z here by the equivalent parameterization of x, y and z here. So this is x, this is y, and this is z. So that means that f of r of t would be, y squared would be sine squared t, and then y squared again sine squared t, and then xz would be t cos t, t cos t. So that is basically our f of r of t. Now dr dt, all we need to do is we need to differentiate this. So r dashed of t, which is the same thing as dr dt, that equals minus sine t, again it's still a vector, cos t 1. Okay, now all we got to do is put that into our, and one other thing, just looking at the limits, how are we going to find out what b and a are? Well, as the z coordinate is the t, all we actually need to do is look at the z coordinate, which goes from 0 to pi, and so therefore we know that b is pi and a is 0. So we know that it's the integral from t equals 0 to pi of f of r of t, which we've already worked out here as the vector sine squared t t cos t, dot product with the r dashed of t, which is this one here, which is minus sine t cos t 1 dt. Sorry, it's got itself a little bit confused there. So basically now let's do this dot product here, so that will be the integral t equals 0 to pi of, and we'll dot product, all we do is we multiply the x, the y and the z components. That will be sine cubed t, minus sine cubed t, sorry, add sine squared t cos t, so that's multiplying the y component, and then add t cos t dt. Now all we have to do now is to solve this integration here, and then we have our answer. So basically let's just try and do that. So let's take this one first here. That's just a standard integration by parts. So the integration by parts, u dv equals uv minus the integral of v du. So let's let u equal t and dv equal cos t. Therefore du equals dt and v equals sine t. I'm just doing this integration by parts over here. So therefore the integral of t cos t dt equals t sine t minus the integral of sine t dt, that's just integration by parts, which equals t sine t add cos t. So we've got that bit there. Now the integral here of minus sine cubed, just replacing that t equals pi and 0, replacing minus sine cubed by cos squared t minus 1 times sine t, add sine squared t cos t add t cos t dt. Okay, so we can integrate this now here. Basically the integral of cos squared sine t is minus cos cubed t over 3 add, well that's minus sine t, so that's add cos t, so that's between pi and 0, add, integrating this one exactly the same way, will be sine cubed t over 3 between pi and 0 again, and then add, well we've already done this one here, that is basically t sine t add cos t, again between pi and 0. Now in actual fact we could have done this all in one go, but it's just as we can split it. So what I've done is I've split that to there, split that one to there, and this one we've already done integration by parts here. And now all we got to do is basically just be a little bit careful but putting in our value. So here basically that is 1/3 minus 1 minus a third add 1, that's that one done. Add, well sine cubed of pi and 0 is 0, so that one's nice and easy. Add, then sine of t, sine of pi is 0, so that's minus 1 minus 1, which equals 2/3 minus 2 minus 2, which equals minus 10 over 3. And so therefore the work done is minus 10 over 3, and that is the answer to this question here using this formula here. Now what we're going to do is we're going to do it the other method, which is using formula 2. So let's start again and do it the other method, and we must get minus 10 over 3. If we don't get minus 10 over 3, then we're in deep trouble. Okay, so let's have a look. Let's put the other formula here. That's p dx add q dy add r dz. Okay, and we know, where are we? We know that p is y squared and q is y squared and r is xz, and we know what r of t is. We know it's cos t sine t. So basically we can rewrite this here as the integral of p, but we know p is y squared dx, add the integral of y squared dy, add the integral of xz dz. Okay, now we've got a couple of little problems here. First of all, we need to look at our limits. Okay, well the limits come from the coordinates. So basically our x goes from 1 to minus 1. Our y goes from 0 to 0, which actually means it's not an integral because we know that's going to be 0. And our z goes from 0 to pi. So we have our limits there, but we still have another problem in that we're trying to integrate here y squared with respect to x, and here we've got to integrate x with respect to z. So what we need to do for this one here is get y in terms of x, and here we need to get x in terms of z. Well, fortunately, from the parameterization, we can see here that y equals the square root of 1 minus x squared. That's from this, because cos squared t plus sine squared t equals 1. And we also know that x equals cos of z, because if z is t and x is cos t, well then x is cos of z. So we can put these two into there, and that gives us the integral x equals 1 to minus 1 of, or y squared is 1 minus x squared dx. Good, now that's all in terms of x. Add, well, the integral between 0 and 0 we don't have to bother about because we know that's going to be 0. So let's just move straight on to z. That'll be the integral between z equals pi and 0 of z cos z dz. Good, so now we've got this integral in terms of x and we've got this integral in terms of z. We've already done this integral before, which was integration by parts. So we can just go straight on here. That gives us x minus x cubed over 3 between minus 1 and 1. Add, and like I say, we've done that one by integration by parts earlier on in the videos. We know that z sine z add cos z. We did that up here. So we know that, and that will be between pi and 0. So all we need to do now is put all our values in. So that's minus 1, add a third, minus brackets 1 minus a third, just putting this one sorted, add 0 minus 1 minus 0 plus 1. And just being very careful with our signs, that gives us minus 2, add 2 thirds, minus 2, which again is minus 4, add 2 thirds, which is minus 10 over 3, which obviously must agree with the other way of doing it. Now, in actual fact, this particular question, it seems to be using this is easier, but it's only easier because, in fact, it was quite easy converting x and y to z and z to x, etc., etc. If it was hard to do that, then it would almost certainly be easier to use this method where we put everything in terms of t. But both methods are equally valid, and sometimes one will be quicker and sometimes the other will be quicker. Okay, well, I hope you found this useful. If you have, please like this video by pressing the little thumbs up button and subscribe to the Gresty Academy YouTube channel. Thank you.